Look at this example. When I move the cursor, at some point the box starts to rotate and scale up, and the opacity also increases. Now when I move it away, it goes the other direction. Now when I reach the center of this box, it reaches like the complete state of the box. This is what I call cursor-driven animation. With cursor-driven animation, you can do a lot of cool stuff. For example, in this demo, I created a macOS-like dock. When I hover over these elements, you can see how it works. And take a look at the adjacent elements here. So they are scaled up based on the cursor position. When I move the cursor closer to it, it becomes bigger. And see how it works. So in this video, I'm going to show you how to create this kind of cursor-driven animation. So first, I'm going to show you how to create it using vanilla JavaScript so we can understand all the underlying concepts. After that, I'm going to show you how to achieve the same thing using Veloxy, which makes the process a lot easier and with more benefits like smoother animations and stuff like that. So let's jump to the code and learn how to do that. In this example, I have this box that does nothing. When I move the cursor, nothing happens. So in the HTML code, all I'm adding here is just a div with the class box. In the CSS code, we have these styling. First, in the body element, we're setting the background color and resetting the margin and padding and setting the width and height to the full screen and centering all the content. For the box element, we're setting its width to 100 pixels and the same for the height, and we're setting some whitish background color and border radius of 20 pixels and opacity of 0.5. Now in the JavaScript code, all we're doing is just importing the CSS file and we have nothing else. Since these animations depend on the cursor position, we need to listen for the mouse move event. So on window, add event listener, mouse move. And in the function, we can accept the event here. In this example, we're working with just this element, so let's just fetch it here. And I'm gonna call it box, document.querySelector, and let's get it by the class name box. We need to get 4 things here: the X and Y positions of the mouse, and the X and Y positions of the box. Let's start with the mouse. We can access this using event.clientX. Now what this value is that it's gonna return the current position of the mouse in pixels based on the current viewport. So for example, when the mouse is at the very left edge of the screen, it will be 0. And when I move it to the very right of the viewport, it will be the maximum width we have. And let's get the same but for the Y position. So we're gonna call it mouse Y and client Y. Now let's get the same things but for the box element. And we can do that using the bounding rect box of the element. To get that, we're gonna say rect and we're gonna say box.getBounding client rect. And this will return an object with a width, height, X and Y positions and other things where we can read the current state of the element in the current viewport. So what we need to get is the box X. So let's say box X. And it's going to be rect.left. And to get box Y, we're going to say rect.top. Now let's log these values to see if we're getting everything correct. So let's console log the mouse. Let's say console log. And for the mouse, we're going to say mouse. And it's going to be mouse X and mouse Y. And the same thing for the box. Let's say box and box X and box Y. Now let's reload and open up the DevTools. So you can see that the X and Y position changes when I move the cursor. So you can see, for example, right now it's 211 and 418. So when I move it, it changes. But for the box, since it's static, of course it will be the same. And it's for now 415 and 382. Now the X and Y position of the box is the left top corner of the element, which means if I move the mouse at the top left corner of the element, it will be the same. For example, you can see we are getting closer to 415 and 382. So you can see now we are at the same position. Now next thing we need to do is to get the distance between the current cursor position and the box position. Now the reason for that is that we need to see what progress we are making based on the distance. But before that, first thing we need to do is that we need to specify some area around the element where the animation starts. So let's say, for example, we have this area. So let's say that at this point, when the cursor enters this point, the progress will be 0. When I move it here, it will be, for example, 10%. When I move it at the middle, it will be 50%. And when I move it at this point, like the top left of the element, it will be 100%. So you can see that we need to calculate some kind of a percentage based on the distance between the current cursor and the position of the element. we need to get this percentage because based on that value, we can calculate the styling for this element. So for example, when the user at the middle point here, we have 50% of the distance, which means we can style the element 50% to where it should go. For example, if we need to make the size of the element once we reach here to double, then when we are at the middle point, it will be 1.5. And the same thing for other styles. For example, if we need to make the opacity 1 when we reach here, then it will be half the value when we reach here. Now to calculate this percentage, we need to calculate the distance between the current position of the cursor and the top left position of the element. So we need to calculate this length. Now, if you are familiar with linear algebra, you know that we call this a vector. Now, first, we need to calculate this vector. To get this vector, we need to subtract the mouse position of the cursor from the x and y position of the element. So this vector is x equals box x minus mouse x. And the same thing for y. Y equals box y minus mouse y. So once we have this x and y position of this vector, we need to find its length. And we can calculate this length by calculating its magnitude. And to calculate it, we can use this formula. The square root of x squared plus y squared. So let's apply these calculations in the code. So let's get the distance vector, and we're gonna say x equals box x minus mouse x, and let's do the same but for the y. And now to calculate the distance, we're gonna say distance equals math dot square root of x times x plus y times y. Now let's log the distance and see. Now when I move the cursor, you can see we are logging the distance between the current cursor position and the top left position of the element. Now when I move the cursor closer to the element, the distance will be shorter. You can see how it gets smaller until we reach the 0, which is at the top left of the element. Now that takes care of calculating the distance, but now we still have to specify some kind of a maximum distance between the element and some point at the viewport. So I'm gonna store this value at some constant, let's call it max distance, and we're gonna do, for example, 200 pixels. So let's say that the 200 pixels starts somewhere here. Now once the cursor gets to this point and further, then we're gonna have some kind of percentage. And it's as simple as dividing the distance by the maximum distance. So let me show you this. So let's say progress equals distance divided by max distance. Now let's log this. Now you can see once I get some point here, it will be 1 because the distance is at 1. Now when I move more, since the distance is getting smaller, then we're gonna get closer to the 0 here. Now we have two issues here. First, instead of starting from 0 when we are at the 200 pixels mark, we are starting from 1. And the second issue is that when I go further from here, so if I move away from the element, it will increase beyond the 1 value. So we need to do two things to fix that. First, we need to clamp value from 0 to 1, so it will never be more than 1 or less than 0. So let's start with that. So I'm gonna quickly define here a helper function for calculating the clamp. So let's paste it here. Now if we pass this progress to it, let's say const clamp progress, and we're gonna clamp the progress value between 0 and 1. Now let's log this. Now if we test it, when we are at this point, it's always gonna be 1 because we can't exceed the value 1. And once we hit the 200 pixels mark, it's gonna get less than that, but it can't go smaller than the value 0. So you can see when we hit this, it's gonna be 0, but after that, it will increase. So that solves the issue of clamping the value. The second thing we need to think about is how we can make it start from 0 to 1 instead of from 1 to 0. Actually, we can do that simply by finding the inverse of the progress value. And that's simply by saying inverse progress equals 1 minus clamped progress. Let's log this and let's try that. So it's gonna be 0 until we hit the 200 pixels, and then it will increase until we get to 1 here. But you can see that the position of the element is specified by the top left corner of it. But instead, it's better if we can set it at the center of this element. So for example, at this point, instead of it being 0.65, it will be around 1. And we can do that simply by moving the point from this position to the center of it by adding half of its width and half of its height. So let's go here and say that the box x is rect left plus rect width over 2. And let's do the same here, but it's gonna be height. Let's save and try. Now when I move, it will increase until I get to the middle of it. And you can see now the value is around 1. Now using this progress value, we need to calculate the styling of whatever property we need to style. For example, let's say that I want to change the box size from the current size to the double of its size using the transform scale property. Now if you know the scale property, you would know that the current default value of the element is 1, which means the default size of the element. Now, if we set it to 2, it will be double of its size. So what we need to do is that once we hit the 200 pixels, it will increase from 1 to 1.1, 1.2 until we get this point where it will be 2. But you can see that the inverse progress only increases from 0 to 1. However, we need it to increase from 1 to 2. How could we change this value from increasing from 0 to 1 to 1 to 2? And then we get to the idea of remapping. So remapping means that we have value that increases in some range. And in this example, the range is from 0 to 1. Now, how can we remap this value to be in a different range? For example, from 1 to 2, or even to any other range like from 500 to 2000. It doesn't matter. It's just we need to define what the new range is. Now, I'm gonna write a helper function for that, where we can feed it the current value, the current range, and the target range we need to move it to. So let's define the helper function here. So it's called remap. Now it takes the current value, and A, B is the first range. In this case, it's going to be from 0 to 1, and then we're going to move it to a different range. For example, in the scale case, it's going to be from 1 to 2. So let's do that below. So we're going to say scale is, let's remap the inverse progress from 0 to 1, and the new range will be from 1 to 2. So let's log this. So you can see it starts with 1 until we hit the 200 pixels mark, and then it will start increasing. It will increase until we get to the middle point, which is around the 2. Now, what we need to do is just use this value in the CSS property. Let's do that. We're going to say box.style.transform, and then we're going to say scale, and the value is scale. Now let's try this. When I move, you can see it starts to increase until we get to the middle point, and then when we get away from it, it will start to decrease until it goes back to 1. Actually, that's the whole idea. Now, we can use the same thing to update other properties. For example, let's update the opacity. It's going to be the same. We're going to say opacity, and we're going to remap it from inverse progress 0, 1, and it will be from 0.5 to 1. And let's add to the styling, style opacity, and it's going to be the value of opacity. Let's try this. Yeah, and it works. And the last one, let's do the rotation. Let's say rotation remap from 0 to 1, and it will be from 0 degrees to 360 degrees. And we're going to use it at the same transform property. So we're going to say rotate, and it will be rotation and degrees. Let's try this. Yeah, and it works. One thing we can improve here is that we can define another inner area that when the cursor enters, the progress value will always be 1. For example, when I start moving here, we need it to reach the complete state at some point here. And once it reaches to the complete state, it should stop animating and it should be at the complete full scale and opacity and all the other values. It will make it easier for the user to interact with this element. But instead of showing you how to do that in vanilla JavaScript, I'm going to show you how to do that with Veloxy. If you are new to Veloxy, I highly recommend watching the introduction video that you can find at veloxyjs.com. Okay, so now I switch to the Veloxy version. So what we have here is that after installing Veloxy, I assigned a plugin called Cursor Driven Animation and assigned it the name of root. Now if we go to main.js, you can see we are importing create app from Veloxy, and then we are adding the plugin here. Let's go to that plugin and see what we have. Okay, if we go to the setup function, we can see we are fetching the box using getViewRoot, and then we're setting some animation to the rotation property. We're gonna see how it will look in a little bit. Now, at the top of the plugin, we can see we are subscribing to events. Now, we need to do this so we can subscribe to a pointer move event. Now, at the pointer move event, we have an event object that gives us the X and Y position of the cursor. Now, you can see to get the progress, all we have to do is to import utils from Veloxy and then call the function point-to-view-progress. So we're given it the cursor position, and at this point it's going to be event.x. Now we are subtracting the half of the width of the box and the same for the height, because we can't modify the box position here. Instead, we can modify the pointer position. So if you remember in the previous example, we added the half of the width and half of the height to the box X and Y position. But since we are passing the whole view here, we can compensate for that in the cursor position. And in the third parameter, we're passing the maximum distance, which is 200 pixels. And below that, we are passing the complete distance. Now, in this case, it's 100 pixels, which means that once we hit the 100 pixels mark, the progress value will be 1, which means all this tiling will be at the complete state. Let me show you an example. When I start moving the cursor, it will start increasing until I hit the mark 100 pixels. Now we hit it here. Now when I move, you can see it will stay at this state, and when I move away, it will be like this. Now below that, we are calculating the scale, rotation, and opacity, and we also have that helper function in the utils. So we're saying remap the progress from 0 to 1 to 1 to 2, and the same thing for rotation and opacity, and then we are just setting that to these properties. Since we have the spring animation or the rotation property, see how this animation looks like. When I move it like this, you can see when I stop, there's some kind of a springy animation here. It's just a nice way to make the animation smoother. So now you know how to create cursor-driven animation. If you have any questions, please let me know in the comments section of this video. I will see you in the next video. Thanks for watching.